Hello students, in the last class I explained about constraint motion, that is motion of connected bodies, and today I will continue from the last class. That is, in last class, in this example, on this inclined plane you have considered this is mass m1 and this is the string, and here this is the mass m2. Okay, so this mass is m1 and this mass is m2. That means I explained how to find the acceleration, then the tension in the string. So still I have to find the force or thrust acting on the pulley, right? That is force acting on the pulley. So observe the diagram carefully. This angle is, we have considered theta. This is 90 degree perpendicular. Then this angle becomes 90 minus theta. Then if you draw the free body diagram of that pulley, you can observe the force acting on the pulley in this direction. This is one force and this is another force. So this is one vector you can consider and this is another vector you can consider, isn't it? Then the resultant of these two vectors is this one only. Again, according to law of parallelogram of vector addition, you can able to find the resultant force acting on the pulley. That is, you will get the force on the pulley F is equals to root over, this is a T tension, this is T tension. Okay. So this magnitude, the resultant vector magnitude, that will comes to be T square plus 2T square cos 90 minus theta. Why? Because in the formula it is cos theta, but this angle is 90 minus theta. Hence I have written cos 90 minus theta. Then this formula, after reducing, you can write it as, that means one more step I will write, that is 2t square. If you take common outside, t square plus t square, that becomes 2t square. 2t square plus 2t square cos 90 minus theta, you can write it as 1 plus cos 90 minus theta, isn't it? 1 plus cos 90 minus theta. This you can able to write it as 2t cos 90 minus theta divided by 2. So this is the force acting on the pulley. And next, let us consider this example. So in this example, this is one block, this block mass is m1 and there is another block, that block mass is m2 on a frictionless horizontal surface. Now you will apply some force on this block. That force is F. Definitely both the bodies will move with same acceleration. That acceleration is A. We have here we can able to find the acceleration of the system. and also we can able to find the normal force, contact force between two bodies, isn't it? For that, let us draw the free body diagram for mass m1. So identify the forces. F force acting in this direction, and here due to the contact, m2 also applying contact force, normal force in this direction, and the block is moving in this direction with some acceleration a. So in the second body, if you consider, if you draw free body diagram for mass m2, and you can able to see that what is the force acting. Again you are applying force on block m1, means m1 is applying force due to this m2 is contact with m1, that normal force. So this normal force will be equal and opposite, and this is only the force acting on m2. It is moving with some acceleration in this direction. Now you write the equation F minus N is equals to, why? Because it is moving in this direction, this is greater, this is lesser, m1 a, and here N is equals to, in this direction no force is there, hence normal force only applying, that means producing acceleration in the second block, m2 a, and this value you place here. Then F minus m2a is equals to m1a, and here F equals, you will get m1 plus m2 into a. Then acceleration of the system is equals to m1, that means F divided by m1 plus m2. So in this way we can able to find the acceleration of a system, and the normal force between two bodies is m2 into a. For example, if you take, this is a 2 kg block and this is a 1 kg block, and apply 10 Newton force, right? By applying 10 Newton force, what is the acceleration in the system? Means the acceleration in the system is a equals 10 divided by 3, okay, 10 divided by 3 meter per second square. That is the acceleration of this system. And then suppose what is the acceleration of this mass? Means again same only, right? N equals m2 into a. So we have calculated acceleration, means if the system is moving 10 by 3 meter per second square, this block also will move 10 by 3 meter per second square, multiplying into 1 kg, then it will give the n value or normal force value. So similarly, one more example let us take. So in this case, take 3 blocks. This is M1 block and this is M2 block, and next one is M3 block. 3 blocks on the horizontal surface. Then you are applying force in this direction, right? Again, the normal force between M1 and M2, that let us take it as N1, and here the contact force or normal force between M3 and M2, let us take it as N2, and the system is moving with some acceleration in this direction, that acceleration is A. We have to find the acceleration and N1 and N2 values. We will see what are the N1 and N2 values and acceleration of the system. For that, we have to consider a block of mass M1, free body diagram for this body, and for second body this is mass M2, and next free body diagram for third one, this is mass m3, and this is for first body. This is the F force acting in this direction. Here which force is acting means N1 force is acting, that is normal force applied by M2 on M1, and the body is moving in this direction with some acceleration A. These are the forces, and if you see on M2 body, this M1 body also applying normal force in this direction, that is N1, and M3 also applying normal force in this direction, that is N2. And if you observe on M3 mass, so this is M3 mass. For M3 mass, the normal force only is acting, that is N2. So this is also moving in this direction with acceleration A. This is also moving in some direction with acceleration A. And if I write the equation here, N2 for this one, N2 is equals to, directly I can write M3 into A. And observe this one. So how to write here? N1 minus, this is the direction of motion, right? N1 minus N2 is equals to M2 into A. And here F1, F minus N1 is equals to M2 into A. And to find N1 and N2 and A, let us take this N2 and write here. Then N1 minus N2, N2 value is M3 into A is equals to M2 into A. Then N1 value becomes M2 plus M3 into A. Then N1 value shift here, you will get F minus N1 is M2 plus M3 into A is equals to M2 into A. Then F equals, you will get M1 plus M2 plus M3 into A finally. Then acceleration of the system, you will get F divided by M1 plus M2 plus M3. So there are two bodies means M1 plus M2, three bodies means M1 plus M2 plus M3. Like this directly you can able to apply formula. No need to derive. If you know three bodies are connected and moving in this direction means what is its acceleration means force upon total mass. So in this way we calculated acceleration. And then this is what N2 force, normal force between two bodies, and this is what N1 force, isn't it? N1 force, that is normal force between two bodies, and this is the acceleration. Suppose let us take a 50 Newton force is acting. This block is 3, 2 and 1 kg, 3 kg block, 2 kg block and 1 kg block. Then what is the acceleration means? Acceleration A is equals to, you can able to write force acting is 50 Newton divided by total mass 3 plus 2, 1 here 6 kg, 50 by 6 meter per second square, isn't it? So this is the nearly 8 point, how much you will get? 1 times 6 8 is 48, 2 means 8.3 nearly, you will get the answer. That is the acceleration of the block. And if you want to find the normal force between two bodies means, normal force means directly you can write acceleration, you calculated, right? How much? That is nearly 8.3 you got. So 8.3 into 1, so here the force acting is how much? 8.3 Newton. And same here, in place of N1 minus N2, if you substitute the values, then you can able to calculate N1 value, N2 value and this acceleration of the system. I hope you understood this concept. In this way we have to solve the problems. And So these are the different applications we have in connected bodies. So next one more important concept you have to know, that is already you know about tension force and normal force. So here in this contact force, one more force also you have to know, that is called spring force. So what is this spring force? Here let us consider this is the rigid support. You have attached a spring. Then we can say this is the original length of the spin. This one spring L0, you can able to write it as original length. And if you attach a load, means what you will observe? You will observe by attaching a load, by attaching a weight, you will observe there is some elongation in the spring. The length has increased. So that distance, let us take it as x. Right, the length has increased. Then what happens here? If you remove that weight, means definitely it tries to regain its original length. That length is L0. That means it will regain its original length, means definitely in this direction some force should act. You know that atomic distance has increased, attractive force will develop. Similar situation in the strings, isn't it? You can imagine like this also. Here there is a spring. This spring is pulling by both person at both ends, isn't it? So in this way you can imagine. Then definitely these persons applying force, right, that is in this direction. As soon they leave, definitely it regains its original length, means here in the spring a force is developed in opposite direction. Here also the force will develop in opposite direction. That force is called as a restoring force. Okay, in the spring a restoring force will develop. That restoring force I will represent as F, and that force is directly proportional to the displacement. That means how much you will elongate, that much restoring force will develop. So here F directly proportional to x means you can say that proportionality constant, you can write it as kx. Here minus sign I will write. Why minus sign? Means applied force is acting in this direction, weight is acting in this direction, means restoring force will develop in opposite direction. This is what spring force or restoring force. And where K is called as spring constant, and that is depend upon nature of material, or we can say that tells the stiffness of the spring. Then K is equals to, we can write it as F by X, its unit become Newton per meter. Remember, so this is the spring force. So same as the in the string, how we will mention the tension force, in the same direction you can represent the spring force. So based on this, a small example problem I will explain. That is, let us consider a rigid support. This is the spring, and to this spring 2 kg block is attached. 2 kg block is attached. Now it is in equilibrium. Right, there is no movement, it is in equilibrium. Then the weight, G value, let us take it as 10. Weight means M into G. 2 into 10 means 20 Newton force is acting down direction. Its weight is acting down direction. This is weight, or let us take it as force. F force is acting down direction. Then definitely the restoring force also will act in upward direction, right? That means before attaching this load, this may be the initial length, this may be the initial length. After attaching the load, it has increased its length by x distance. Then restoring force is developed in spring, that is kx, and k value also you take, that as 10 Newton per meter. So k value is given, weight is given. You know that restoring force is acting in upward. Both the force are that means this upward force and downward force equal magnitude. Why? Because I said it is at equilibrium. Then directly kx you can able to write it as 20 Newton, isn't it? Restoring force is kx is equals to F, that is 20 Newton, and this k value is how much? 10 Newton per meter second, Newton per meter. This equals 20 Newton, and you can able to find the value of x. X equals how much you will get means x you will get as 2 meters. The elongation produced in the spring, that will become 2 meters. In this way, a simple problem I explained, we can able to solve the problems. Remember, the restoring force means that is k into x in the spring. And next concept, equilibrium of a forces. So what is meant by this equilibrium of a force means, let us say this is a body. On this body various force may act, right? Then the body is at rest. That means we can say the forces are in equilibrium. So it is defined like this. Equilibrium of a force means the vector sum of forces, the vector sum of forces is, or the vector sum of forces acting on a body, the vector sum of forces acting on a body is 0. So we can able to say the forces are in equilibrium. They are compensating. Various forces may act, still the body is at rest, means the forces are compensating each other. Maybe one force acting in this direction, another force is acting in this direction. They may get cancel each other. Because of that, the body is at rest. Then we can say that the body is under static equilibrium. Okay, two types of equilibrium will come. One is static equilibrium and another one is dynamic equilibrium. So when we can able to say static equilibrium means when the body is under rest, even though various forces are acting, but the vector sum of external force is 0, then we can able to say that is a static equilibrium. When we can able to say dynamic equilibrium means if the body is moving constant velocity, and the net external force or sum of the external force is 0, then we can able to say the body is in dynamic equilibrium. So to understand this concept, equilibrium of a force, let us take concurrent, coplanar force. So what is this concurrent coplanar force? So let us take on this body different force may act, one force in this direction, another force in this direction, one more force is in this direction, like that. That means they are acting at a common point, or we can say the line of action of the forces is passing through a common point. The line of action of forces passing through a common point, then those forces we can able to say as concurrent forces, and all the forces are in the same plane, like this an xy plane, then we can able to say it is a concurrent coplanar forces, right? So like that, consider a concurrent coplanar forces. 3 concurrent coplanar forces. One is in this direction, it is acting. I'll write here. This is one force acting in this direction. Let us take this force as F1, and one more force that is acting in this direction. Let us take that force as F2 force. And one more force, let us say acting in this direction, let us take it as F3 force. So this is the concurrent coplanar forces, the line of action of all the forces that is passing through this common point, or you can able to imagine a body here. So if the body is under equilibrium, okay, there is no acceleration in this body, means you can consider as F1 force vector sum of forces, F1 force plus F2 force plus F3 force, the vector sum of forces acting on a body is 0. That means here this is F1 and this is F2. For F1 and F2 you will get the resultant force in this direction, right? This is the resultant of F1 and F2. You can apply that parallelogram law of vector addition concept also here. In this way we can able to represent, right? So this is what resultant R. This resultant of F1 and F2, that I can able to write it as directly. I'll write F1 vector plus F2 vector. So this body is under equilibrium, means definitely I can able to say that F1 force plus F2 force should be equal to minus F3 force. So these two are acting in opposite direction. The body is under rest, the forces are in equilibrium. And then, so while solving problems, if we have 3 forces like this, this is, let us take P vector, and this is, let us take it as Q vector, and this is, let us take it as R vector. So P, Q and R vector. And then this angle, let us take it as, or this is take P, this is Q and this is R vector. And this angle, let us take it as alpha. That means this is the angle between R vector and Q vector. So this angle, let us take it as beta. That means this is the angle between r vector and p vector, and this angle, let us take it as gamma. Alpha, beta and gamma. This is the angle between q vector and p vector. So whenever three unknown forces or three unknown vectors are there, means we can use to solve the problem. We can use Lami's theorem. Okay. So what this Lami's theorem will state means, that is, according to Lami's theorem, this P vector, or if you consider force, this P force is directly proportional to the angle between, sine of the angle between other two forces. This is one force acting in this direction, right? This P force is directly proportional to the sine of the angle between other two forces. That is, that angle is sine alpha. And next, if you consider Q, this Q force is also directly proportional to sine of the angle between other two. If you neglect this one, means other two forces become P and R. Between P and R, what is the angle? Beta. This Q directly proportional to beta. That means the sine beta. And remaining is R. This R is directly proportional to other forces, sine of angle between other forces, that is sine gamma. Then according to Lami's theorem, we can able to write P upon sine alpha is equals to P, this one, Q upon sine beta. This equals to R upon sine gamma. This is very, very important theorem. Remember this formula: P by sine alpha plus Q by sine beta. P by sine alpha is equals to Q by sine beta is equals to R by sine gamma. This is called as Lami's theorem. I hope you understood directly. If one vector is acting in this direction, means directly you take opposite angle, P by sine alpha, like that. If R vector is there, means opposite, you see gamma, you will see, isn't it? For Q vector, the opposite will become beta. In that way, we can able to take the ratios. So based on that, a simple problem I will explain. So listen here. This is a rigid support, and this is one string, then this is another string. Here there is a object. Here there is a object. The angle between these two strings is 90 degree perpendicular. So here there is a block. This block is under equilibrium. That means tension force will act in this way. In this string, tension force is T1. In this string, tension force is T2, and weight of the object will act downwards. That weight, let us take it as F. That F is equals to mg. Mg is acting downwards. How many forces are there? 3 unknown forces are there. And this angle, let us consider it as 150 degree, and this angle, let us take it as 120 degree, and this angle is, that is 90 degree. So in this type of problems, three unknown forces are there, the body is under equilibrium. We can apply Lami's theorem and we can find the unknown forces. So how to apply? What is that? P by sine alpha is equals to Q by sine beta is equals to R by sine gamma, right? So here how to apply that one force acting F divided by its opposite, you see 90 degree you are observing, that is sine 90. I can able to write this equals this T1. If I observe T1 divided by what is the opposite angle here, angle between other two forces, that is one sine 150 degree. So this is equals to T2 by sine 120 degree. So T2 means this is the force, opposite is here, angle between, sine of the angle between other two forces means 120 degree. Like this we can able to apply. Now you can able to write F divided by sine 90. Sine 90 means that is 1 F, and this is equals to sine 150. Sine 150 means sine 90 plus 60, that is cos 60. 1 by 2 T1 you can write. This equals T2 by sine 120. Sine 120 means cos this one sine 90 plus 30, cos 30, root 3 by 2. That means here 2T2 by root 3 you can write. Then you can write that F equals 2T1, or T1 is equals to, you can write it as F by 2, or F equals, you can write 2T2 by root 3, or root 3, this one T2 is equals to root 3 F divided by 2. In this way we can able to solve the problems and we can able to find the value of T1 and the value of T2, isn't it? If we know the mass, suppose 10 kg is given means 10 into 10 100, then T1 becomes 100 by 2, 50 Newton, or T2 is equals to 100 root 3 by 2, that is 50 root 3 Newton. In this way we can able to find the tensions in the string. So the condition is there should be three unknown forces to apply Lami's theorem. Otherwise another method also we can solve this type of problem, that will become very lengthy. So in the next class I will explain how to solve in other method also. So choose which is convenient to you. In that method you practice. Thank you.